Okay, class. Just want to give you some quick tips on the questions in assignment number 8. Okay. So first, let's look at the first. The first 3 questions are continuations on triple integral. Basically, we'll focus on evaluating triple integral using spherical coordinates. So here's the first question here. Okay, so you have an object or region which is sandwiched by 3 things. Number 1 is a half sphere, so the outside here is half sphere, and there's this xy plane, and then there's another sphere, a little one here in the middle. So the xy plane, the sphere, the half sphere here, and the little sphere give you the region, and we're looking for the volume of that region. Alright, so the outside here, the half sphere is x squared plus y squared plus z squared equal to 1. Equal to 4. Okay, yeah, because rho equal to 2. So the little one here, this sphere here, is this one. Alright, so that's the little sphere. So this sphere has a center at 0, 0, 0.5 with a radius of 0.5. So if I draw that sphere by itself, right, it's center at 0.5 with a radius of 0.5. Okay, so then you have a circle basically here. Oops, let's draw that circle again. So you have yeah, it's drawings. Okay, and then so that's basically the bottom of the sphere is tangent to the xy plane, right? So this is the little one right here, and this sphere in xy coordinates is this. Okay. Now the first part of the question is to prove that for the same sphere we can also use spherical coordinate to describe it, and in that particular case, then it's rho equal to cosine phi. Okay, just like this half sphere here. Why rho equal to 2? Because if you rho is the distance from origin to where the point is. So if you draw a reading lines from here to the point on the surface, doesn't matter you draw, the rho is always 2, right? Yeah. Basically, what you end up with the rho equal to 2, or here you're trying to prove rho equal to cosine phi for this one here. So what you do is basically you plug in the spherical coordinates, right, into the x, y, and z. Okay, so basically x equal to rho sine phi, and cosine theta, y equal to rho sine phi sine theta, and z equal to rho cosine phi. Okay, so what you need is just plug these 3 equations into here, here, here. Do some simplification using trig identity. You'll be able to end up with the rho equal to cosine phi. Now, what does this rho equal to cosine phi mean, right? So basically, what it means is, if you start from origin and then you draw, okay, to anywhere, to a point, anywhere, any point on this surface of sphere, if this is P here, then rho OP is basically the rho we're talking about here, right? That's the definition of rho. And phi is the angle between z-axis to where this reading line is drawn here. Okay, that's phi. Okay. So this rho, and this portion and here, this is 0.5 and this is 1. So rho equal to cosine phi. That's the connection between rho and phi. As a matter of fact, we can also derive this uh, relationship using geometry. Okay, so for any point on this surface of the sphere, we can always construct a circle. Okay, basically it's a circle if you cut this sphere. Okay, um, for example, maybe I'll draw it here again just to make a better one here. Okay, so let's draw the XY coordinate, and then I'll draw a circle. Okay. Enlarge that a little bit. Okay, more. Okay, so we have another circle right here to indicate the 3D. Center. Yeah, so this is X, Z, right? Okay, so if I pick a point anywhere in this circle and anywhere on the sphere here, we can always create basically a circle on the sphere, okay, like that. So that point must be on the circle, So what does that mean is, if I connect this from origin to that point, and then, okay, connect this top vertex to that point, we will have a right triangle at here. Okay, so basically, if I simplify this a little bit here, we have a circle at here, and this is origin at here. Then connect to this point to the surface, and connecting the vertices to here, we got a right triangle. This side hypotenuse is 1, the length, and from here to here is the rho. From this is z-axis to where you draw the line, this is a phi here. See, apparently using this triangle geometry here, the rho cosine phi equal to 1 over rho. Right? Sorry, cosine phi equal to rho over 1, right? Rho over 1. So that's why rho equal to cosine phi. That's the same results that you're going to get from here. Okay? Yeah. So as a matter, you're going to use these results in the second part of the question. Okay, so second part of the question is to find the volume, right? Sandwiched by the three things that are here, basically between xy plane, the half sphere, and this little sphere here. And we're going to basically evaluate the volume using triple integral. Okay, so rho squared, right? Sine phi, okay, d rho, d phi, and d theta. Okay, yeah. So that's what you're going to evaluate at here. And what we need is to figure out the limits for each one of the integral here. So we're going to integrate the rho first, phi and theta. So we need to find the limits for the rho. According to the steps we have been talking about, so what you do is you're going to draw basically arrow lines, okay, starting from the origin, and draw the arrow lines, okay, out of the region we're looking for. Okay, so this is the arrow line we draw it here. Having a hard time to snap. Anyway, maybe draw you them in here. Okay. So first contact between this arrow line and the region is on the small sphere. Second contact is between this arrow line and the region is on the bigger sphere. So from origin to the first contact location, from here to here, give you rho mean. From here, origin to the second contact location, give you rho max, right? Yeah, that's the procedures finding rho mean and rho max. Now, if I look at this thing here, rho mean is from here to here, rho max is from here to here, so it doesn't matter where you draw. The rho max is the easiest. Rho max is always 2. Now, rho mean, this is basically for the first part of the question. Rho mean is the distance from O to any point on the surface of a small sphere. As we just showed, rho equal to cosine phi. So your rho mean at here is cosine phi at here. Okay? So rho mean is cosine phi. Right? Then the next step is to sweep these arrow lines, okay, across the region to find the limits for find the limits for the phi. So apparently the phi, remember phi always starting from z-axis, so you will have to rotate from here and up to here. So that gives you 0 to pi over 2. Okay. The last step is for this region, the shadow in the xy plane is this circle. So we can draw arrow lines out of the circle here. Okay, and theta is basically that's projection of this one here, and then theta is this angle, okay, between from z-axis to where this projection here is. Sweep this line, right, across the whole shadow, find the theta limits, and apparently 0 to 2 pi. Now, once you have those limits, the evaluation is fairly straightforward. Okay, yeah. That's problem 1. So let's look at problem number 2. Very similar. Okay, you will evaluate the volume. Okay, between the xy plane, and then this portion on the sides is part of the sphere, rho equal to 2, and then there's another portion. Okay, and this is the cone here, right? This surface here is a cone. Okay, so in spherical coordinates, the cone is indicated by phi equal to pi over 3. You can look at page 16 of lecture 15 and 16 notes. Okay, so to find out why phi is pi over 3, why phi equal to pi over 3 is a cone. So in Cartesian coordinates, that cone is basically this one here. Essentially, if you substitute the 3 equations, right, into here, you will get this phi equal to pi over 3. So what we need to do is, just like the previous case, starting from our so let's lay down the 3 integrals here. Okay, so starting from origin, okay, you draw an arrow line, okay, out of the region. The first contact between this arrow line and the region is 0, so rho mean is 0. Second contact is on the sphere, rho equal to 2, so rho equal to 2. Then you sweep this one across the region. So apparently the first boundary is over here, and the second boundary is here. And for this boundary, the phi angle is pi over 3. And for this boundary, phi angle is pi over 2. So pi over 3 to pi over 2. And the last step is to basically sweep the reading lines across the whole shadow, which is this disk here, and that's give you theta to pi over to theta to 2 pi. Okay, so that's it. That's the way you evaluate this integral here. Okay, so number 3 is actually relatively easier than the first two. What all you need to do is to basically evaluate the moment inertia about a z-axis. The formula is this. But the first part is evaluated using cylindrical, then spherical. Okay, so cylindrical z, okay, r theta, cylindrical rho phi theta, right? Yeah. So in the previous assignments, you exercised finding limits for cylindrical here, and then you do it again. Okay, and this time you will do the spherical. But the last part, calculate Iz using cylindrical or spherical, really doesn't matter. Okay, yeah. If you're going to use a spherical coordinate to evaluate this triple integral right here, so chances are, okay, if you calculate it carefully, you will end up with an integral. Essentially, part of the integral, you end up integrating this sine phi cube, okay, d phi. Okay, there are certain limits for the phi, okay, 0 to pi over 2, of course. So the question is, how do you evaluate this integral here? Okay, and this is where the hint will come into handy. Basically, you can substitute sine phi cube with this one in here, and you will be able to carry out the integral. So as a matter of fact, this one comes from the results that you have obtained in 246 assignment. Don't remember which assignment now, but it's assignment related to the complex number. So you can take a look at the assignments, how this is derived here. That's one relationship. Okay. In the solution of the assignments that you will see is I've also provided another way of evaluating this integral. For that one, you can use an integral by parts. Okay, so basically separate the integral like this, and then you can do integral by parts to evaluate. You'll get the same results. All right? Yeah. So that's the first 3 assignments. Now for the questions number 4, 5, 6, you can look at the one of the old videos I created, okay, in previous years for question 4, 5, 6. Okay, I'll post the link. Basically, check out the link. It's a video link, okay, for previous year assignments. Now, in the previous assignments, in that link, I'll post that on the basically the video. You can click the link and it will directly, bring you there. In that link, the questions might look pretty different because there are 2 questions in that video links I didn't assign in these assignments. Okay, but you can use those 2 questions exercise that as a sort of a reference. All right. Okay. So let me know if you have any questions. Okay. We have probably 1 more assignment to go, and then that's it. We're done for this term. Okay. Thank you.